Right, thanks. So as you just heard, this session has been recorded, which means that after the session is done, the video will be available on the platform for the next period, I think around 4 or 5 weeks. And after that, it's going to be available through YouTube. So this means that if you don't want yourself to be shown, please keep your video off, and if need be, or also your audio off. Otherwise, you'll be shown in the video. So with that out of the way, welcome to this session on FAIR for machine learning. The link to the slides is, let me put the collaborate notes first on the chat window, as well as the link to the slides, which is here. And you can follow along this way. The idea is that we can keep the collaborative notes, to keep notes and get your feedback on the progress that we had around this topic. So a few housekeeping things. So first of all, this is an RDA event, which means that everything falls under the RDA code of conduct. We'd appreciate to have your questions and your feedback either on the chat, and when we can copy back on the Google document, or direct on Google document, whatever you feel more comfortable doing. If you want to speak, please raise your hand, and we will try to address the question. So I'll start directly with the introduction. So this is the agenda for today. After doing the introductory part, I'll do a quick update around what FAIR is for those who are not aware of, as well as a quick update on the recent effort around the FAIR for user software. And there is a parallel session, another session, RDA, that happened a few hours ago, with a follow-up happening a few hours from now. So I'll give a link to that as well. Then Dan will give an update, introduction on this particular effort, the FAIR for machine learning, and what we've done so far. And then we are going to have a follow-up discussion on a presentation from Silvio Tossato from the University of Padova, and the effort that Elixir has been doing around machine learning and standards for machine learning, and provide an update on that, followed by an update from Dan about a relevant effort that takes place under the context of the FAIR for high energy particle physics, if I recall this correctly, that is being run in the US. The last part, which is going to be the main part of the session, to be honest, is going to be a discussion about what is the next steps. And this is where I would like to have your feedback on what might be the best approach to take here to put this forward. So without further ado, I'll go to the context. So the FAIR principles essentially have been defined for quite some time now. The first sort of formal publication was in 2016 by Elixir et al., which were about data. So the main concept was that the principles were put together to ensure that the data are available for people and machines alike. They were split across 4 main pillars: findability, accessibility, interoperability, and usability, hence the name FAIR. So each of those principles, as you can see here, are further refined into specific statements. And all those, again, as you can see here, are clearly geared towards data, which is appropriate given that the FAIR principles at that time were defined for data, but ultimately the FAIR principles can be applied to any kind of Elixir object, and that was the original context. The problem is that if you look at the original FAIR principles, the text itself includes data and metadata directly, and the shorthand that is used in that sense is meta parentheses data. So in terms of data, that actually does make sense. You can see the principle applied directly by dataset creators in repositories that are allowed for these datasets to be searched around, to be filtered. And ultimately, the target audience of the FAIR principles are the stakeholders that are in charge of dealing with data in whatever context, data and their metadata. The problem is that research objects are not only data. So we have non-data research objects. Technically, they can be stored as data. That is true, but this is sort of a very obscure way of describing all of research objects as kind of bits and bytes. Ultimately, they're not just data. So if you look at the principles themselves, findability, accessibility, interoperability, and usability, they still stay the same. The concept still holds. But the problem is when we are discussing about how the actual implementation goes, how they are actually implemented across the different research objects. So how their objects are created and used, where they are shared, and how and where, in particular, the corresponding metadata is stored and indexed. So to that end, there are several different efforts that are in place trying to define, implement, and ultimately, of course, adopt those principles for these particular contexts. So there are, as you can see here, several different efforts for FAIR for non-data objects, for training, for workflows, for research environments, and of course, the FAIR for research software principles, which I will go into a bit more detail in a sec. All of those, the main purpose was to review the FAIR principles as they are, as concepts, and going into the different statements of the principles, see whether they can be interpreted as they are, used as they are, adapted, or even possibly introduce new statements that are really geared to address those particular efforts. So as an example, I will provide some information to the FAIR for research software effort that's being done also in the context of RDA. And it's a collaboration of a joint effort of an RDA working group, a Force 11 working group, and the Research Software Alliance. So this started essentially in September 2010 after being endorsed by RDA, and it's now in its final steps, ultimately completing the work in a few months in March 2022. The actual principles have been reviewed, discussed by the community in regular monthly calls and town hall meetings, and essentially leading to a particular outcome of those principles that are up now in the community discussion. I think they are now in the phase where being accepted by RDA as a final output, with the next step being to find the corresponding adopters that will take those principles and apply them in the work. So if you look at the motivation that was behind this software group, again, as I mentioned, the FAIR principles should be applied to this object, but looking at the effort of this working group is to look at the particular adaptation and adoption of these FAIR principles for research software in particular. And there are several efforts in the past about how the FAIR principles should be applied for other digital objects. And I here provide a couple of recommendations from several different initiatives that identified this particular requirement. You can find the actual output of this working group here. This is the link, but I would also encourage you to join, if at all possible, given the different time zones, the repeat of the session that the RDA for Research Software group had a few hours ago. That will take place later today at 10:30 p.m. UTC time in breakout 6. You can find the link to the actual session there. So with that, I will give the floor to Dan to provide an overview of the efforts we've been doing so far in the FAIR for machine learning.
Okay, thank you. Should we go on to the next slide? So as we've already said, we have this interesting situation that we have FAIR principles that claim to and are intended to apply to all digital objects. And here what we're trying to do is to focus on how these FAIR principles apply to machine learning. And as you'll hear, machine learning means lots of different things, and there's lots of different ways that this could be done. And this is part of the I think the question and the discussion that we want to have as we go forward. But again, just to repeat, the EASC Fair Practice Task Force commented or made a recommendation that, that recognized that the FAIR guidelines will require translation for other digital objects. And so machine learning models and machine learning processes may be part of that. And that's, again, what we want to talk about. So next, please. Okay, and repeating even once again, we have the FAIR principles that claim to apply to scholarly digital objects without any regard to what those objects are. But then when you look at them in practice, they really focus on metadata and data, not on other objects. As Fotis has mentioned, we have different work that's looking at how to translate them and interpret them for other objects. If we think about machine learning models specifically, we could ask, are machine learning models data? And you might say that they are, because you could think of them potentially as a set of parameters and options for a particular framework, just some values that that can be plugged into something. You could also think of machine learning models potentially as software. Right? A machine learning model is an executable object that takes input, some data to be analyzed, and provides output, some knowledge-based information about that. Or they could be a combination of data and software and workflows, for example. Or they could be something else. And we don't really know what the answer to this is right now. And this is, again, part of what we want to talk about. Next, please. So some of the other issues that come up is when we look at the FAIR principles as originally defined, again, for data or in the context of data, these principles are very dependent on archival repositories. Right? A user who's creating a data set cannot make that data set FAIR by themselves. They need to put that data set into a repository which contains the metadata, and this repository is actually the thing that makes the data findable and accessible. So FAIR for data really is a partnership between dataset creators, curators potentially, repositories as infrastructure, and maybe others as well. Software doesn't have that same dependence on archival repositories, but it does have that same dependence on some kind of platform. Software is typically not shared via archival repositories. It's not really typical that somebody would go to Zenodo or Figshare or something else and look for software there. But they would typically get software via social coding platforms like GitHub or GitLab, or through package management systems like PyPy or CRAN, for example. And so again, if we think about these two different things, and then we try to say what happens with machine learning models, again, the answer isn't clear. It's certainly possible, and there are examples of machine learning models that are shared and searchable via repositories. There also are machine learning models that are searched and shared via executable platforms. And then there are machine learning models that are beginning to be shared and searched through other things like DL Hub, which is a deep learning hub, OpenML, which is a platform for things. We'll talk about these, I think, in another couple of slides. And then the last question that comes up when we're thinking about FAIR and machine learning models, or I should say a last question on the slide, is the fact that models are based on the data that was used to train them. So should the model and the training data be shared together? And we don't know the answer to that either exactly at this point. Okay, so next, please. All right, so for a variety of different reasons, Fotis in the context of projects that he's part of, me in the context of projects that I'm part of, other people who are interested based on their own projects or based on more academic effort, have been starting to come together and talk about what are the open questions here, what are possible answers, and what could we do? And so the things that we've done up to this point have been to create a poster at RDA VP16. This was the first virtual plenary. And I would say, well, I guess I shouldn't say, but I'll say anyhow, The poster was a very unpleasant experience because we really hadn't figured out how to do poster sessions in virtual meetings. But it is available, and if you want to look at it, you can see it, and there's a little snapshot of it on the upper right. We decided that a poster in a virtual meeting wasn't really a good way of having discussion, and we had at the next RDA virtual plenary a BoF instead, which was much better. We also gave a talk at the Fair for Machine Learning, the Fair Festival on Fair for Machine Learning Models. We had a community call in July of this year where we tried to bring together people that were interested in the BoF or in the Fair Festival work, or that we had found through other means, through Twitter and through other things. We gave a talk, I guess, about 2 weeks ago at the Damolos workshop, looking at linked objects and data for them. We have this BoF that we're doing today and having a repeat session in 5 or 6 more days, depending on your time zone. And then we also will have a BoF at the Supercomputing 21 conference in a couple of weeks, looking particularly at people that are interested in high performance computing and how that overlaps with machine learning and what comes out of that. So again, we've been doing a number of efforts trying to gather people's interest and trying to build up a community through a variety of methods. Next, please. Okay, right. So as I was saying, that when we think about data, we could think about data being a combination of the people that create data and the repositories where data is stored, as well as potentially communities and projects. For machine learning, it seems like repositories are not exactly the right thing, but we have platforms instead. And again, this is a hypothesis. This could be completely wrong. If we're happy to talk about this and be corrected. But at least in terms of platforms, there are at least 3 that we know of that are working in the space of trying to provide a service by which people can share models, publish models, run models in many cases, and find other people's models. So DL Hub is one of these that's fairly general for machine learning models. Kipoi is specific to genomics. And OpenML tries to combine the models as well as the data, as well as an environment in which you can build new models and analyze results and get advice on better models. We also have communities that are involved, in some cases discipline specific, in some cases more focused on the AI part of things. So the Stoya Alliance and Elixir, both effectively representing I would say different parts of life sciences. And then Claire as a confederation of laboratories that are working on AI research in Europe. There's a couple of projects I'll mention. I'm sure there are far more projects than this, but these are ones that have come up. So there's the Fair for High Energy Physics project that I'll talk about later and don't need to talk about here for the second. And then another US project is called HPC Fair, which is trying to provide a generic HPC data management framework for both training data and AI models and to make them both fair. So again, one thing that would be great is if you have ideas of other either platforms, communities, projects, or anyone else that really is relevant and we should try to get involved. If you could put any of that into the notes, that would be very helpful down at the bottom where we just have general notes. Okay, next, please, folks. Okay, so the other thing that we're going to do here is to have 2 talks. One from Elixir and the machine learning focus group from Silvio, and then I'll talk about this Fair for High Energy Physics project, and then we'll move into some discussion and talk about what other things we can do collectively, what questions we want to answer, what kinds of projects we want to do. All right, so Fotis, I think back to you maybe, or to Silvio, I'm not sure.
Yeah, I can stop sharing my screen now. And I think Silvio should be able to share his screen. And I will yield the floor to him then. I can definitely see your slides. So the floor is yours, Silvio.
You may be muted, however, Silvio, and
Yeah.
I'll comment that the slide seems to be remarkably small compared to the screen. But we can probably live with that if we could hear
Okay,
you.
sorry. No, I was just commenting on the fact that I have an ultra wide screen here, and therefore, sorry if it messes up the perspective and if it's too small. It's just that otherwise it all ends up on the screen, and yeah. Okay, I think you will probably forgive me for that part. So yes. I think I can just start then. The Elixir machine learning focus group was mentioned. First of all, I would like to say a few words about what Elixir is. Sorry, let me just, yes, okay. There you go. So Elixir is an international organization, and it's essentially centered around Europe. Currently has 23 member nodes, which are usually countries plus the European Bioinformatics Institute, Cambridge, UK. And the main mission of Elixir is to connect the national data nodes in the life sciences. So this is the main European infrastructure for life science data. And one of its purposes is to align the services from national Elixir centers in a federated ecosystem via common standard services. And it also provides the people and technical capacity to enable fair data stewardship within every European life science project. It's a pretty large endeavor because it contains almost 400 different teams spread across over 20 different countries. So yeah, it's quite large, and so far it has also been contributing a number of smaller projects to try to bring together the various components of the Elixir data nodes. The machine learning focus group of Elixir, in a nutshell, is essentially Jen Harrow from the Elixir Hub, who's the coordinator also for the tools platform, Fortis, and myself. And the goals of the machine learning focus group are, first of all, to define standards for machine learning, which is also what I'll be talking about for the rest of my today. Then also to contribute to benchmarking of machine learning tools, training for machine learning, the fair and reproducibility of the machine learning, and integration across different Elixir communities. So this is all centered around the life sciences, but it is pretty broad within that. It has gathered wide interest across many different nodes, and we have consistent participation of over 40 different members representing over 10 different nodes. And one major output, which is what I'll be talking about today, which are the DOME recommendations, which were just published this month in Nature Methods. And of course, also we are maintaining a connection to industry, in particular the Pistoia Alliance. So what is the problem with machine learning in the life sciences? Well, first of all, that it has been undergoing an exponential growth. So you see here on this plot that the number of publications from last year, where you had the keyword machine learning plus something which is characteristic for life sciences, was on the order of 9,000. So there's a lot of publications in this particular field of machine learning. And one of the not so nice facts is that about 20% of the publications did not apply any evaluation to the methods. And even for those who did, usually it's very heterogeneous. So in a way, one of the dirty secrets in the field is that machine learning papers for bioinformatics can be highly problematic, and that many of the things which are submitted to journals are probably not well performed, or at least you cannot really gauge how good or bad they are, because the authors are probably not intentional, but are omitting certain key elements which would allow you to do a full technical evaluation. So hence, after a longer discussion, which is one of the things which Elixir is usually good at, to bring together various experts, we came up with a set of recommendations, which are called BoF. And these are the recommendations for supervised learning in the life sciences. And these have the aim to improve the standards in this field. Now, supervised learning is still the most common case of machine learning in the life sciences, although it's by far not the only one, of course. And in any case, this is important to kick off also the discussion, and there's still a lot of work to do. So the DOME acronym itself stands for Data Optimization Model and Evaluation, which are the four main components we have identified. And you can see the analogy to the FAIR acronym here. Certainly, the paper itself was published in the October issue of Nature Methods, and actually it has helped to kick off an entire focus in Nature Methods about machine learning methods and how to improve their standards. So there's an interesting editorial in this issue describing it. So what are the four components of the DOME recommendations? Well, the first one, data, is related to spelling out clearly in the publications. And here we are always talking about how to improve the reproducibility and the trust you can have for publications. So what is the provenance of the data? How was the data split into training and test set? What is the redundancy between the different splits of your data? And finally, is the data made available? And here on purpose, we have not gone as far as requesting that everything should be available, because sometimes there may be reasons why this is not possible, but at least we ask the authors to specify whether it is available or not, so that then the reviewers first and the readers afterwards can judge whether this is appropriate or not. The second component here, the optimization, is really about the algorithm being employed, and something which is very relevant for bioinformatics and the life sciences in general is whether meta predictions have been used, because it's so much easier to get very good accuracy measures if you're already using other state-of-the-art methods. But in that case, you're probably not adding so much to the field, and so this should be spelled out clearly. Then it's some of the technicalities related to the algorithm. So how was the data encoded? What were the parameters, say for a machine, for a neural network or a support vector machine? What are the features being used? How was the fitting to the data done? And again, is all of this available for the users or not? The third component is the model. So here, something very important, which can trigger its own discussion, the interpretability of the model. So you probably know that neural networks are black boxes, essentially. So this, again, should be clear, because sometimes there are methods which are being enthusiastically described as being interpretable. But if you look closer, they're really black boxes. So this is something where the author should be stating what they are really proposing. And then the execution time can be important, because for large-scale applications, this is one of the main problems. And then finally, again, is the software in this case available? And finally, regarding the evaluation, first of all, is how was the evaluation of the method carried out? So what are the accuracy measures, for instance? How was the performance of the method on the various data sets? And a comparison to other existing methods should have been carried out, or it should be explained why it hasn't been carried out. Last but not least, it's about the confidence of the evaluation. So is it statistically significant, for instance? And once again, we also have an item about the availability of the evaluation, which can be important in order to make everything reproducible. So this is, in a nutshell, the definition of the DOME recommendations. As I said, this is meant for journal articles or even conference articles, if you prefer, but anything, in any case, publications. So what we are suggesting with the DOME recommendations is that all of these points could be addressed in a supplementary material table, where the points are clearly spelled out so that the reviewers first and the readers afterwards can have a clear idea of what is going on with machine learning and judge for themselves whether they trust the method being proposed or not. Finally, we have a website for this, with dome-ml.org. And there you can find more information about the DOME recommendation themselves, and also pointers to the current set of questions and how these can be answered and included as a supplementary table in the publication. With that, I think I've said all. So thank you for your attention.
Thanks, Silvio. I'd say that we give a couple of minutes for questions if there are, although I would like to see this during the discussion as well to make the connection. But if there are any questions from the audience, please free to raise hands. Karen, please.
This maybe have been addressed, and I apologize if I've missed it, but why is it that machine learning models are being treated differently than any other statistical model or some more other types of models? Is there a distinction there that they warrant different treatment somehow?
The machine learning models, you mean?
Right. So as opposed to, large climate models or general statistical models, or, I mean, are these recommendations?
Of course.
Yeah, sorry.
No, that is a good question. In principle, you can apply several of the elements of the DOME recommendations also for statistical models. It's just that traditionally in bioinformatics, there has been an abundance of publications using machine learning. And everybody in the field has been complaining behind the scenes that the review process is difficult. I mean, I myself have been both an editor and a reviewer on scores of times or even more. And there are a lot of papers where you can make sense of what is in there. And you always were missing something where you could point the authors to say, hey, follow these recommendations and it will help you improve. So statistical methods are also used in bioinformatics, but they are perhaps less common. So there is an entire subfield which deals only with rather standard machine learning methods such as neural networks. Plus, of course, there has been over the last year a lot of publicity coming to bioinformatics and machine learning thanks to AlphaFold, which has essentially solved the protein structure prediction problem, which was for several decades thought to be as difficult a problem to predict as forecasting the weather or predicting the stock market. And now having a method which is based on machine learning, and because this is a deep neural network, which has performed so well, has generated a lot of interest in the field. And of course, then not everything is as good as the top methods. And so there is an added pressure in terms of publications being received, which are probably not quite as good and which should be sorted out. Does that answer your question?
Yeah, thank you. I appreciate that.
Welcome.
Thanks, Silvia. I see two more hands, Dan and then Amy.
Yeah, so I guess I had a question, but I was going to comment, I think, first on the Karen's question. At least to me, the thing that's different here is that machine learning models basically are black boxes, unlike statistical models or climate simulations or something where you can actually get inside and understand what's going on, or you know what the algorithm is, at least that's being applied. So it does seem like these are kind of, I don't know, treating them like boxes in some sense means that they're really objects in a way that is, I think, different than an algorithm or a model or a simulation. But just my opinion, I don't know. The question I was going to ask, I guess, for Silvia though, was I think when I think about FAIR, it has fairly high level goals in some sense, but it's also fairly limited. Right. So you can have fair data that is bad quality data, right? You can have fair data that is fictitious. You can have fair data that doesn't really mean anything. Right? You can have fair software that is full of errors. And so I think the DOME recommendations are interesting because it looks like, I don't know, I guess what I'm trying to figure out is what the overlap between the DOME recommendations and FAIR is, because it seems like the DOME recommendations are going very far in lots of directions, where the FAIR recommendations potentially would be much more focused and narrow. And so I'm just kind of curious, I guess, from your point of view, what you think the overlaps of these things are, and kind of how much of DOME is relevant to FAIR, or how much of FAIR is relevant to DOME?
Well, I think the short answer is my interest in following the session today is precisely to figure out how the two are related. And that is because the FAIR data and the FAIR principles in general are, of course, as you said, yeah, perhaps more narrow in the definition, although I'm not sure if that is the way I would call it. I mean, as soon as you try to come up with something which is relatively abstract in order to encompass as much as possible, then in a way you're always having something which is broad. There are certainly several areas where the DOME recommendations overlap with the FAIR principles. Main point here was that they are applied to a specific domain. And we had actually to whittle that down from all of bioinformatics or all of the life sciences to a more specific subset, which is supervised learning at the moment, precisely because it's so vast. I mean, we had lots of discussions about how things which are applicable to molecular data for sequences, for instance, which are essentially just glorified and very long strings of letters, are difficult to apply for something which are structures, so 3D objects where you have the coordinates, and they are even different if you have images from microscopes or things like that. So this has been actually the reason why everybody in this field has been complaining, at least as long as I'm in this field, which is over 20 years, and still nothing really had been happening. So in a way, it's actually quite surprising that it has been possible to distill a set of simplified rules. And I think that's probably because of this exponential growth of the number of papers being published in this area. Earlier, it was easier to ignore the problems because they were relatively limited. But now, I mean, with AlphaFold, for instance, this has been published in Nature itself, and as 2 papers back to back this summer. So we're really talking about a big splash here. And so without any additional checks on what is going on in the papers, it will really become problematic. So yeah, I'm not sure if I have fully answered your question. But,
no, I mean, I think that's fine. I think there's slightly, I think your goals and the goals that I have are slightly different, but they do overlap. And I think we've explained some of the area of overlap. So I think that's helpful. Thank you.
All right. In the interest of time, I see another hand, so I'll move to the question, but then I'd like to move on to the next talk as well. So, Huayin, please. Sorry if I mispronounced the name.
Yeah, it's Huayin here. Thank you. Yeah, I'll just ask this quickly. So, do you think the DOME principle applies to both applications that use the novel algorithm, or just use the algorithms out of the package?
Both, actually, because especially for novel algorithms, some questions will become more important, like the one about interpretability. One of the things which happens with a number of publications is that they claim to have developed a novel method and a novel algorithm. And so it's just not clear whether it's really novel, and especially they claim to have developed these novel algorithms, because then they can say that this is interpretable or that it has some other advantages. So at its core, the DOME recommendations really is just spell out clearly what you have been doing in a way that it can be evaluated from a technical point of view. So it's relevant for both cases. But especially for novel algorithms, it can be increasingly useful, because being non-standard really means that all sorts of different things can be happening there. Okay.
Thank you.
Welcome.
Perfect. Thanks, Silvia, and thanks everyone for the questions. I'd like to move on to Dan now and the presentation of the next talk. So I'll share my slides again. And Dan, you have the floor.
Okay, thank you. Looks like we're missing the bottom of the slide, but I guess it doesn't matter a huge amount. Okay, perfect. Now everything's there. Maybe it was just a delay in rendering. Yeah, so I'm just going to talk briefly with 2 slides about the FAIR for High Energy Physics project. So the U.S. Department of Energy basically recognized that there was a lot of interest in machine learning and a lot of thoughts that it could be applied productively to a number of interesting questions, science questions in high energy physics. But the problems that it called out were that we don't really have good public, well-created, well-structured training data that can be used to generate models. And the majority of high energy physics researchers don't necessarily know how to make data that they have structured well enough that others can use it for creating models. And once we do have models, it's not completely clear how we compare them, how we find each other's models, how we actually try to understand how they are applied within science. So again, in the context of high energy physics, the goal of the project that we proposed and which was funded was to create fair AI data sets and models, specifically data sets that would be used for training models, to automate the reusability of these data sets by humans and machines with as little human intervention as possible, to try to bring together new connections between data and models, so to make sure that when we have models, the data that they're based on are available, and that we can understand what models could be applied to what data as well in an automated way when we can. And again, with the kind of end goal of not necessarily us, but the high energy physics community as a whole and the machine learning community who's interested in high energy physics, being able to build more quickly domain-informed, rigorous, interpretable, and reusable AI models that adhere to FAIR principles, where again, we don't necessarily know what that means at this point, but that's what we're trying to do. So we wanted both to generate these models, to generate processes by which others could generate these models, and to figure out how do you do this in a fair way, and what does fair mean in this context. Okay, next, please. So we're doing this basically by trying to do a bunch of things ourselves, and then trying to document what we're doing and share them with others. So we are so one of the first things that we did is that we created a FAIR high energy physics data set, which is in this archive link in the middle. We created the data set, we tried to make it fair, we tried to evaluate if it was fair or not using tools that we could find, and then we asked 2 experts outside of high energy physics to come in and help us analyze this. And so we tried to, in this preprint on archive, which is a paper that's under review now as well, share basically the process that we went through and the questions that we asked, so that others could go through a similar process and have a similar checklist to make other data sets fair. We're also then using that data set and others to create AI models. And we're beginning to share some of those AI models, in our case through DL Hub, but we're also looking at some other platforms and some other technologies for doing this. And the intent is that, again, we want to build these models, make them usable by others, and DL Hub has the ability to do that, as well as the ability to publish them and get DOIs for the models. And the intent, again, of doing this is that we want to share the process that we've gone through so that others can use a similar process to develop best practices within the high energy physics context and examples within that context for how data should be shared, how models should be built, and how those models then also should be shared and reused again within this high energy physics community. We think that probably we will gain some scientific advances between models and data, but primarily we really want this to affect the rest of the community. This is not intended for us to do this kind of science, but for us to make it easier for other people to do this kind of science. Because the high energy physics data sets are quite large and in many cases require lots of computing both to generate the data sets and to analyze them, there's also a high performance computing HPC piece to this, but there's also an edge piece to this that we want to be looking at different parts of the high energy physics experiments, like trying to look at the data that's generated in real time potentially and understand based on trained models which data is significant and which data can we throw out without ever saving. So again, I guess that's kind of just a quick summary of the project. We're, I'd say overall, trying to influence the community by providing examples is maybe the tagline of someone. Okay, so photos back to you.
All right, thanks. All right, I just saw, okay, the chat window. So are there any questions for Dan? I'll stop sharing my screen briefly.
I know high energy physics isn't as exciting as life sciences. But...
All right. In that case, let me go back sharing my screen then. So we now move to basically the second part of the discussion of the session, which is the discussion. And there are some specific questions that we'd like your feedback on. I'll go through them now, but after that, I'm going to be sharing the Google document where I would like to also capture directly your feedback there. So the questions are specifically looking at the at FAIR. The question is, should fairness address only the machine learning models, or should this also take into consideration processes and or platforms? That's question number one. Question number two is, if we're talking about FAIR, should it be applied to machine learning as it is? Or, in other words, should we start trying to redefine fairness for machine learning? Or do we need to, or could we rather reuse the FAIR principles for data or software or both as they are and be done with it? In either case, looking at the FAIR principles, what are the changes that are needed? What are the questions that are sort of still open and need to be further discussed? And the last, which is really practical, given that there is an interest on the machine learning, on FAIR for machine learning, is there any interest in actually creating a new working group in RDA to deal with that? Or should we, is it sufficient to work on a white paper or a more research output to define that and self-organize to do that? So these are the questions that we'd like your feedback on. I'll stop sharing the slides. I think that's the last one in case. And I will open, I will start sharing my Google document if I find how I can do that again. There we go. So this is a Google document and these are the questions. Right, so I will start directly. I see people have already started putting stuff in and I also see a hand. So I'll give the floor to Rainer first.
Well, Thank you very much for this initiative, making machine learning data models and so on fair. To your questions, I would nearly answer all your questions to yes, because I think it's a good approach to make machine learning, the data, the models, as well as the software, to shape it in a reproducible way. And I think this is directly in the direction of RDA. And working out recommendations how to do that, I would just trying to say here, definitely this could be a good idea for a working group. I myself, I'm one of the co-chairs of the IG Data Fabric, which has now the name, or will have the name, Fair Digital Object Fabric. And with the Fair Digital Objects as one of the recommendations and outputs of RDA, we are aiming at especially having a digital object which is pointing to a data object, to a software object, or whatever it is, a kind of a bit stream or resource, which describes itself. So, which means that the type of the object and even the formats and the metadata schemas are referred in the object itself. So this has been, so I see here a huge parallel attempt to that. And maybe especially I would like to invite you also to show your use case with machine learning use case in the Fair Digital Objects Fabric group, and to and maybe we can see some overlap in here.
So Rainier, you were a little bit soft for me. I guess one thing I wasn't completely clear on is the Fair Digital Object work that you mentioned. Is that a project? Is that an RDA group? Is there a link to it that we can capture?
Yeah, currently the group is the IG Data Fabric, which is currently has produced a new charter and which is in public review, which is called IG Fair Digital Object Fabric.
Okay, thank you. If it's
RDA IG.
Okay, if it's possible to put a link in the Google Doc where somebody's typing notes for you, that would be great.
I will do it.
Thank you. It looks like David was also typing something in the general notes. I don't know if you want to go ahead and your hands up. Yes, please go ahead.
Sure. So first, thanks for this session. This is really fascinating, and seeing some of the work that's already been done really resonates. Obviously, there's a complex interplay here between multiple groups, really any group that's dealing with the data that will feed these models and so on and so forth in RDA and FAIR for software. But I think as we consider this and scope what might come next, the relevant technologies are sort of exploding really quickly. Like Dan already alluded to the fact that there are these platforms, hubs, whatever you want to call them, and those things are going to continue to change as people have ideas about how to solve a problem that we haven't perhaps clearly defined yet at this point, but it's just sort of organically coming together. And so I'm having a hard time wrapping my head around this idea of exactly what we can solve at that sort of conceptual level of what needs to be there, and separate that from the technology questions versus simply grabbing onto solutions people have already come up with and driving in those directions. That's not necessarily bad. Those people have spoken with their time, right? They had a good idea and they did something, and DL Hub is a really great implementation as an example of that. But that's not necessarily going to serve the underlying need for ultimately reuse and reproducibility of these models, right? Are we serving being able to actually evaluate the model, helping reviewers? Are we serving people who want to grab these things and use them in another way? So that's not really a question. That's just a bunch of thoughts that I'm mulling. So thanks for listening to those, I guess.
Yeah, I think those are certainly good questions. I guess the thing that I'm taking out of that a little bit is that maybe we need to do a better job of defining use cases at the beginning.
Yeah, I think that's.
No, go ahead, David. Sorry.
No, sorry. I was just responding that yeah, that's definitely one thing to take. Go for it.
So what I was thinking, so I fully acknowledge the fact that focusing on one technology or another is not even an easy exercise, and I'm 100% in favor of dividing, as you said, the conceptual work from the corresponding implementations. And I think, in my mind, that would be the primary concern of any such effort under this context of FAIR for machine learning. And especially, this is sort of going back to this particular, the second question here, which is, if we're talking about fairness for machine learning, how are the actual principles now defined for machine learning without taking into consideration the actual implementation? Because implementation, in my mind, is following up from principles. If we have the statements and we agree with the statements that define the fairness in machine learning, then we can see what would be the most appropriate implementation of those, or whether something already exists or needs to be adapted and so forth. So my primary question, to be honest, in this session is the ones that I've just highlighted. If we are talking about FAIR for machine learning, do we need to start thinking about a redefinition? Or is it sufficient to start thinking, okay, machine learning essentially data in software or in the workflow or something like that. Let's actually go ahead and split the machine learning process into its individual components and say that, all right, we defined fairness for machine learning through the definition of the individual components and be done with that. So that's sort of my main question. Again, this is quite from a personal point of view. So fully absolutely 100% in favor of splitting conceptual versus theoretical versus implementation. But this leads back to the same question. What are your thoughts about that? And this is not, of course, to you, David, sort of to the entire room here.
Yeah, I mean, it's a great question. It gets to the fact, is FAIR really the right frame for this, or is there some augmentation or different way to think of FAIR? And there are a lot of pieces. Is it ML? Are we looking at FAIR for the model? Are we looking at FAIR for the entrained model? Are we, there's all those pieces.
Are there any other thoughts before because I don't want to monopolize the discussion, and I do have generally strong feelings about all of those questions, but I don't want to be biasing people in. So any thoughts on any of those? Seeing here on the document as well, regarding the question about addressing only machine learning models or processes or platforms, Karen has a point to sort of create the principles for models and its extension to software. And then going from then onwards, trying to see specific issues for the algorithms themselves, and sort of bringing on from then. To be honest, I like the elegance of the approach, but at the same time, it feels in my mind to be a bit too software heavy in that sense, be that the algorithm or the implementation of the algorithm itself. And it omits a lot of the iterative concepts that a machine learning process might include, plus possibly not take into consideration a case where it's not a single piece of software, but sort of a chain of steps, one after the other, that actually lead to the expected result. But again, that's me. Are there any thoughts or counter arguments or other ideas?
I think that's really fair. If I can use that word, I think that's a reasonable reaction. So then are you saying that you would prefer to focus on fair workflows, or am I reading too much into that? No?
Again, I would say the exact same thing, same argument for workflows, because if you focus on workflows, then you're missing the components themselves. So if the workflow is fair, it does not necessarily imply that the individual piece of software are fair, nor that the data required to do the training is fair, et cetera, et cetera.
Yeah.
So essentially what I'm advocating basically is to really go to identify what we mean first by saying that we want fair for machine learning. What is the machine learning part? Define that one, and then go back to the assessment of the fair principles and individual statements and how they hold against this definition of the machine learning. But I also see two hands as well. So Hojin first.
Hey, I think I agree with your thinking, and I think a relevant question is that if we have a fair software, fair data, and fair workflow independently, do we get a fair model? The answer is probably not necessarily. So I think it makes sense to evaluate the thing holistically.
Thanks, Reggie. I'm just trying to keep notes as well. So thanks. And I see Nicholas has also a hand.
Yes, maybe just a comment on that. The idea of making all components of the machine learning process fair at one time is probably not necessarily to be answered right now, because finally it really depends on the purpose, right? Someone wants to reuse the model, the other one wants to just reuse the training data or whatever. So probably just going step by step, and yeah, just starting with the verification process for one thing might be sufficient for now. And yeah, I mean, if everything comes together at some point, that would be great. Just to, yeah, see it from that perspective, maybe.
Thanks, Nicholas. Are there any other thoughts on the subject of? I see a hand, Lars. Yes, please.
Yes. I think that also another issue, as I wrote it in the document there, is that fair for machine learning also needs to incorporate the interoperability more than other models have focused on earlier, because quite a lot of the earlier works on fair has been focused mostly on the F and the A and maybe the R, but very often we kind of skip the I. And I think that for machine learning specifically, this needs to be stressed more than most works does. Most work has been done in when it comes to defining, because of the nature of machine learning being the machines doing the searching, so to speak. And I think that's something that we need to also lift forward in this type of discussion, rather than just the standard FAR that's usually discussed.
100% agree about the interoperability, and in the effort that we've done both initially at some point within the Elixir tools platform, and after in the RDA research fair for research software effort, as Dan can also say, is that interoperability was one of the tougher principles to try to interpret in different domains, because interoperability can have completely different connotations depending on who is actually describing and what, even if you're talking about data only or software only or workflows only. So absolutely in favor of that one. David, please.
Yeah, I put the comment in the doc. I was going to say +1 to Lars, and I think that the special ML interoperability. A problem that we run in, I work in the material sciences, and we run into a lot is the need for interoperable labeling or annotation for supervised learning, that we really struggle with having multiple data sets that have been annotated differently. And now we just have to re-annotate them all if we're going to learn over the whole data set. So that really, that's a huge barrier to what we want to do, which is just grab a bunch of data from different places and get the big data set. We haven't solved that problem technologically, but it's certainly something that should be part of our consideration of interoperability in this space.
Thanks. I see Dan has hand a quick comment, mostly because it was really an excellent segue for me to mention that. To also address Dan's questions earlier today about DOME, this is also how I see DOME in fit with the FAIR. It's not overlapping with FAIR, but it's sort of an enabler of making machine learning FAIR from then onwards. Making sure that all those attributes are captured would definitely help answer questions about the fairness of the machine learning process itself eventually. And to address your comment about the data required to make this happen, another effort that is being sort of hopefully started under the data discovery paradigms intergroup in RDA is about how machine learning can be effectively used for data discovery, in the sense of ensuring that the relevant data sets are retrieved, they are of the relevant quality, and sort of can be effectively integrated to enable machine learning afterwards. But again, that was a very side note because sort of peaked. Dan, please.
Well, no, maybe I was going to say something similar to that. I mean, I greatly appreciate what David is saying as a problem, but I also kind of don't view it as a machine learning problem. I view it as a data problem. And so I think that's one of the, I mean, when again in the high energy physics project that we were doing, that was one of the biggest questions that we had was what are community standards for explaining the data and for labeling the data and for the metadata around it? Is it community standards of physics? Is it community standards of high energy physics? Is it community standards of the CMS experiment? And they're all slightly different, and they don't necessarily agree. And again, how much detail should we go into in explaining something? Are we assuming that the person who's going to look at this is another CMS experimenter, or is somebody else at CERN that's on a different project, or is somebody that's in graduate school that isn't part of any of these projects but has some basic knowledge, or is a computer scientist that wants to find an interesting data set to try to build new machine learning technologies? And so in all those cases, the answers are different. And I mean, I think this is all really important and it's really interesting to look at, but I'm not completely sure if it's things that fit into this FAIR for machine learning question, or if it's just that the context of machine learning brings up the fact that we didn't really solve these in FAIR data yet.
Yeah, but I think there's a reason it wasn't solved is that the things that are special to machine learning, the community who's been working on the metadata and other things for context in the data part of FAIR doesn't necessarily know how to solve these problems. So I think there is a special corner of that needs attention. Whether it happens here or somewhere else, I don't know. I need to be quiet now. Sorry, too many comments.
Oh, comments are useful. All right, so if I'll try to do a quick summary of the points so far, mostly to make sure that I don't have them too jumbled in my mind. So the consensus so far is that, generally speaking, this is definitely a challenge worth investigating. I haven't had a comment so far saying that, okay, this is not it's not worth looking into. There is an indication based on the discussion so far that it might be useful to not look only at the models themselves of machine learning, but also to try to encompass the entire process of the machine learning, from data to training to the model itself. Talking about the platforms that will enable that maybe the next step in the process, as they are more on the implementation side rather than the contextual one. Looking at the FAIR principles themselves, and I'm not sure if I'm summarizing this effectively, my understanding is that if we end up with a consensus of what the definition of machine learning could be in this case, it is worth trying to interpret and assess the FAIR principles from the beginning, rather than relying on the existing efforts of data, software, and workflows respectively. So essentially starting the work from assessment and moving onwards from there. Are there any objections or counter arguments to this summary of the discussion so far?
For what it's worth, I think it's a good summary. It's reasonable. Yep.
Cool, thanks. Silence usually goes for no, or if I don't feel strongly enough to say something again, so it's equivalent. Which brings me to the next point. So as far as I know, this is a more broad discussion, so we'll skip it for the time being, unless there are some strong feelings. And from what I see in the notes, there is nothing really specific. So I'll go directly to the last question, which is how we should actually move forward from that. This is a much more difficult debate, mostly because at the various interactions we had with other communities in the past, since the last timeline at least, it's been moving back and forth from actually having a group to not having a group to working on a white paper or sort of organize them ourselves. So at this point, the question I'm posing is, should we look at organizing and drafting something like a charter for a group in RDA, be that an interest or a working group? And are there any thoughts on that? I see that there are basically 2 points here on the Google document. One is yes for an interest group, the other is yes for a working group. And in both cases, it appears that the white paper is sort of the expected outcome. I see Gabe has a hand. Sorry, I'm mispronouncing Sergey, I'm sure.
Yeah, go Payne. I go with Payne. I think for a working group or white paper, it may depend on what do you want to do with the outcome, right? If you want to have more official meaning or something official about your outcome, working group might be a better way to go. However, if we're going to focus on the result of the discussions and the recommendations, a white paper might be quicker to accomplish.
You're muted. So if I may answer this question, the outcome in my mind would always be a white paper or similar to that, scientific or otherwise, it doesn't matter. What I would like to do, again, completely personally speaking, is to have a list of these are the FAIR statements that fit FAIR for machine learning. With this is the definition of machine learning for this particular set of rules, for this particular set of statements. With that, a whole lot of other activities can start, from how to implement, how to start interaction with the repositories that can support that, and so forth. So that is kind of the response to this particular question. And in the meantime, because I saw this on the chat window, if we are talking about a working group or any kind of activity, if you are interested in actually helping and leading this activity, please indicate so in the Google document as well. So Dan, please.
Sorry, I was just thinking about working groups and interest groups and products, and so just I put this in chat, but I'll just mention that that working groups generally are created in order to produce a product over some fairly short period, almost always 18 months, I think. although it's an RDA rule, it's not really a general rule. And whereas interest groups are more, can be longer running and can spin off working groups to do particular activities, but are more in some sense a community, I think, to bring people together. So I guess one thing is we could do both. We could have an interest group that also starts a working group where the working group is intended to create a white paper. I guess from the context of the 4-year funded project that I'm working on, where we have just finished our first year and have 3 years to go, I feel like I actually need some guidance on how do we know if the models that we're producing are fair or not. So I would be a little bit disappointed if the only thing that we have is a white paper, but maybe that's all that we can do at this point. All right, so I guess part of the reason that I'm really interested in this is that I want guidance, and I know that I don't know enough to create that guidance myself. And my hope was that we could gather enough people that were interested in this that we could kind of jointly define what fair means for AI models or ML models that's not specific to a discipline, but crosses multiple disciplines. But I'm not, it's not completely clear to me if there are other people that think that that makes sense or not, or that we could do something like that in 18 months. So I don't know, I guess, okay, so the last thing that I'll say as I kind of continue rambling is that we started this about a year ago with the VP16 poster. And I think the reason that we haven't actually converged on something in this year is that these questions are kind of hard. And when we talk to different people, we get different answers. And so it still is pretty unclear to me how we bring these things together. But I guess I'm kind of vaguely leaning towards maybe an interest group that spins off working groups to do some specific things might be the right idea at this point.
Thanks, Dan. Rainer, please.
Oh, well, hitting exactly the same spot like Dan. If you go for an interest group beforehand, it gives you more time. An interest group acts as a communication and coordination group, and it can spawn up, it can spawn working groups. So an interest group would give you the opportunity to define the expected outcomes of a working group. It gives you the opportunity to collect a critical mass of people. So, and this is really important to have a base of, let's say 10 people or something like that, who agreed to spend their time in producing outputs for a working group. What you already have, and what I really, really like, or what we have use cases and adopters, potential adopters from material science, looking to the direction of David, from biodiversity, Silvio, and from high energy physics. And that's really, really great.
Thanks, Rainer. Right, I don't see other hands, but I see a lot of people sort of typing in here, and it appears to be apparently that a new interest group might be the majority of points that I see here, at least. People appear to be more, they like the flexibility more than the time constraint of the working group. From my side, I find this useful, but it still will require a very specific definition of what the interest group will be about. Because FAIR for machine learning as a title for an interest group, for example, is already quite narrow, unless we want to move it one step further and try to think about additional activities that may come out of this interest group by itself. But I'll stop mumbling. I see Amy has a hand. Amy, please.
Hi, thank you. I just wanted to give a +1 for the interest group idea, and also to keep in mind that with the interest group, it doesn't preclude you, it doesn't preclude us rather, from also taking immediate action towards outputs or recommendations. You can start the interest group, and at the same time, in kind of the formation of that, indicate the formation of task groups or focus groups, which is something we've seen work successfully in other interest groups who are focused on that 18-month timeline to produce the thing. And it's more about having that discipline within the group itself to say we've created that community of collaboration and communication with the interest group, but we're also dedicated to actually getting some product out there in the world. And so within this interest group, we have task groups or work groups or focus groups, or however you want to term that, that are dedicated to a timeline for producing an output. That's all. Thanks.
Thanks, Amy. All right. Let me see the chat window. All right. I was about to say, I see that Dan beat me to on the chat. Looking at the time, we have 5 minutes left of the session, and I definitely don't want to go beyond. It would be nice to have an action plan. So it's clear that there are people here interested to contribute, which I'm really grateful and thankful for. So for this reason, I would say that, let me actually do a quick check. We should have some names and emails here. So, all right. So if you're interested in following up, we can set up a series of talks, of chats in the next couple of weeks after the plenary ends, so that we can start organizing these particular efforts, how we can set this up as an, again, potentially interest group, what would be the scope, and what would potential the short-term outcomes of this interest group? Because again, because it's not time limited, it would be nice to start thinking if we can have something done even prior to an interest group formally starting under RDA. And this might be also useful for people who would require some more of an outcome in a short-term period. Would this be an appropriate approach? And I will also try to reach out to people that have been engaged in the past through the community call that we had in July or the previous VP. I should have the contact details somewhere so I can get everyone involved. Would this be fine with everyone, basically? Thumbs up, silence sounds good. Please speak up if you're against.
Sounds like a good way forward.
So again, just to be very explicit, I guess, we have, sorry, I'm going to say this probably wrong, Nana and David, who have said that they would be willing to help. Sorry, Lars as well. Sorry, I didn't see that. Are there, if there's anybody else, please also put yourself down so that we can kind of be clear. I mean, I think from the Fair for Research Software group, it was very obvious that we, well, sorry, it wasn't very obvious. I think we were quite successful with having 9 co-leaders and then a bunch of other active people, and then a much larger community of people that were following along and reviewing. And so we definitely kind of need to have people at all different levels. But right now, I feel like we need to focus on the people that would potentially be the co-leaders to get things started.
All right, I saw someone else also, Wajin, also on the chat, so I copied that as well. All right, so there is a clear list of people here, so I can definitely follow this up. Okay. Are there any other final thoughts? And again, I just to repeat exactly what Dan said, I don't think that we should aim for 1 or 2 people actually doing that. It's going to be definitely more than a few co-chairs that be leading that. Having more people actually as a steering committee, I think worked phenomenally well. So I would like to replicate this idea. but more people to actually really contribute would be the critical part here. All right. Thank you also for being here like 3 in the morning, which really is some next level dedication in my mind. Well done, and many thanks for doing that. All right, so we are 3 minutes to the hour. I think we can stop a few minutes early and have an earlier break. I'll stop sharing my screen now. Thank you all for joining. Many thanks to Sylvia and Dan also for their respective talks. Thank you all for being here and for providing for feedback. And I'm really hoping that we'll be able to engage even more closely in the coming weeks. There is going to be a repeat session of this session in next week, as I think it's on the 9th or 10th, depending on the time zone. So I'm not saying please join again. I'm not going to be joining because it's going to be like after midnight for my time. But I'll try to capture the notes from that time as well. So thanks everyone. Enjoy the rest of the plenary and I'll see you around.
Thank you all. That was
Bye
really
all.
great.
Dan,
Thank you. Bye-bye.
You have a minute.